quickly, in order to get started, you just go to your web browser and type in python.org, right? Just like you see, I'm having to type it again so that yeah. So if I just type python.org, like I have it typed, once it gets open, it will lead me here. This is exactly the Python website, the official Python website, and you could see some codes already here, but quickly we want to get it downloaded. So once I just highlight the download, I didn't even have to type it, I didn't have to tap it. So once I download, you see the all the releases of Python, the source codes, the Windows. This is for the Windows, this is for Mac operating system, and all of that. So you can sign for other platforms. Anyone you have, you could just follow the prompts and get it downloaded. But once I highlight the download icon, I'll find out that already I have download pass for Windows Python 3.12 or 12.5. Right. The warning I would give is not to download Python that is not that is not 3 points. All right, version 3. Don't go downloading 2 points, no matter the other numbers behind it. Just go for the Python 3, and I think it's wise to just get this downloaded. I have Python 3.12.4, so this is Python 3.12.5. So once you just tap it, you see you will find out that on your download version you find it almost downloading already, but I have it downloaded, so it's fine. So once I have that done, I can just come up here to my Windows, and I'll now search, right? Sorry for the, so I can just type IELE, right? So this is exactly what I downloaded. So once I tap it, I'll see that it takes me to the file, the interactive shell editor for Python. It opens it basically. That's what it does. It will just open it. So I had it open already. So this is the interactive shell for Python. Here is basically where you write your code and it is run. This is basically the platform for Python, right? But this ideal shell is not all. You can write your code in GitHub for Python programming language. You can have other editors like PyCharm where you can write those your codes. But Python, this is like the basic one you could use to write. So anything you write here will be run, right? So for instance, I want to write print this is all in capital letter, and Python programming language is case sensitive. So I have print hello world, and once I do that, it comes up, it runs it, print hello world. It just runs it immediately after the line. All right, so again, my name is Enoch, so I can ask it to print my name, right? Print my name, right? So I can ask it to print my name is Enoch. I can just ask it to do that. Once I do that, it will write my name is Enoch. So you see, you can write your code in the interactive shell, which is the first Windows that you open. It will show out your codes and it will run the codes there. But you don't want to have this continual, because for instance, you want to write a code, a program that helps you just do things, and you're not yet running. So once you're hitting the enter button, it keeps going and printing. That will cause for a problem. You may not want to use this to write your code. And this interactive shell is also it just does Python. And remember, Python is easy, so you can do expressions like 2 plus 6, right? So you could do things like 2 plus 6, to get it run. You could even do multiple operations, right? And it will follow the order of precedence, based on what we were taught in mathematics, which is of higher higher importance. It begins to run that like that. So you could do 8 times 2 divide by 1 divide by 2 plus 6, okay, divided by 2 plus 6, or yeah, minus 2, right? And once you press it, it hits you 12.0. So they write it like that, but that's not the point. So you could write your expressions, you could have evaluate it, evaluate whatever expression to a single number. Python can do that for you. There are other types and data types and all of that, so we'll get to know that. But for this video, is basically to show you how it works exactly, excuse me, exactly what it is and how it runs. So in order to get this code written without having to get it run every single line, so that you can have everything concise, you could open the file editor. And what to do that, you just go to your file. Once you go to your file, you go to new file, and the file editor will come. I can just drag the gist and just shift it a little bit. Yeah, so I have it here. So you find out that this looks like a twin of the interactive shell, but here it allows you to write your code without having to execute it immediately. You are done writing your code, then you can now run it and it will appear. You can now run it here, you can type it here, and it will run here and give you the output here. So this can just be basically like your screen, like your output, and this is like your back end where your source code is written. So I mean, literally you can write anything here, right? You could say go get me a cup, right? Once I hit the next button, it goes there without having to run it. And I could say bring it here. I could say bring it here. You see, nothing happens. So basically, this is where you just write your codes. And like I said, it's like the twin of this. So one distinguishing factor you have here is that this allows you to write, the distinguishing difference is that this allows you to write your code from top to bottom without having to run it or execute it. And this will not, right? This will not allow you to do that. Another difference, again, given that they look like a twin, is that you could find that you have this triple angle prompt, right? This triple angle prompt here that you see here is not obtainable here. So you could just keep writing your code, and it doesn't, you can't see that. So this little things would help you differentiate between the interactive shell and the file text editor, right? So for example, these same things that we did here, so this same hello world, my name is Enoch, we'll type it here and then get to see the output and see how it looks and what's the difference and how it operates, right? So I can have print hello world, right? So print hello world. All right, print hello world, and I'll go to the next line and say print my name is Enoch. All right, my name is Enoch, or this. All right, so once I'm done with this, I'll try to run it. I'll go to the run icon, and once I type the run icon, it comes out here. So you have run module, you have F5, sorry, you have run module, you have F5. So you see, I can basically tap this or directly tap F5 to get it run. So once I hit it, I'll now find out that I need to save this, because this is where the file directory will have to come. So once I tap it, you see save before run or check, right? Source must be saved, right? Okay, to save, right? It must be saved. I must have saved this my source code in order for it to run. So this is where we start to talk about file directory. So I could tap OK, and it will lead me to the file path where Python saves all her programs. So it goes from this is where you see it from. You have programs, then it goes to Python, then it goes to Python 3.1.2, and here in anything I hear will save here. So but maybe I don't want to go that very far in trying to save it. This is like an if else statement that was saved here, and I don't want to go this very far, so I can quickly just go to my desktop, and once I'm at my desktop, I will hit it, and then I'll create a new folder, right? But I had created some folders already, so maybe there's no, so I can type create a new folder, and I'll type in the name of the folder. But I've done that and I created my Python practice, or let's say Python prac, right? And once I tap it, double tap it, I see I downloaded one as tryout. I'm just trying it out, so I can have this again to as tryout. So I can say try in, right? Just to give it a name, try in, right? All right, I'll trying, basically trying. So, and I save it. Once I do that, then this code here will now run. You see the difference? So you have here hello world, my name is Enoch. Unlike you have hello world, my name is Enoch. Unlike what you see here. So this is looking a little more beautiful, and a little more organized, and also very neat, right? Unlike what you have here, which is a little bit scattered, right? So that's, yeah, from here to here is a little bit scattered. So you have, you see the file path. The file path here is, it goes from users to PHP, that is the PC, to desktop, to Python Prac, to tryout.py. So this is the file directory, this is the file path for this particular code. Right, so I'll still use this file path, this code, and let's try as something else, where maybe a little bit more interactive now. So we'll try to see if we can create a code that will ask us to, that will ask of my name and greet me or salute me, right? So I can use the hashtag, which is a comment, which denotes a comment, and I'll talk about that in a bit. So let's say a program that asks my name and salutes me, right? Ask my name and salute me. Now in Python, there's something we call a comment. A comment is and usually is being denoted by this hashtag. A comment basically is what causes a line of a program to become non-executable, so that as much as these programs are like this. So for instance, if I come here and I add an hash to this code, even though that wouldn't happen, um because it had already run, right? So if I try to add an hash to it, it will make this entire line non-executable, right? So you will see it from this example that I'm trying to do, right? So because I will run the whole program, but you find out that nothing about this comes up, or nothing about issues. It wouldn't show me an error, it wouldn't show me a syntax error or anything, because it's a non-executable code. This line of code becomes not executable by the computer. It just shows this is for my own personal use, and for any other person. Comment helps source codes to be readable and to be easily organized, part of the characteristics of comment. So this is just for my use. So again, let's still ask it to maybe ask me my name, and by that I'll do maybe enter your name, and the next thing is, okay, whatever I enter, let me say my name, let it be um impute. So I will not ask it to, all right, so I will ask it to print all right, your name is, okay, my name is whatever I typed, right? So I would have that. All right, so I would have that here. Your name is the name, and all right, your name is that, and I also ask it to, right, all right, your name is, all right, so this, I didn't close this, so this is not, all right, yeah, so your name is, okay, I'll not ask you to print okay, I cannot ask it to write my name and salute me with, okay, we, all right, sorry, with honor in our hearts, we salute you, right? Is basically to just, so all things being equal, if this is correct, it's gonna work like this. Or maybe this may not be so nice, so how about we do it this way? So I will come here and ask say take for granted I'll be a mister, right? Take for granted I'll be a mister. So um right, so I think this should be better. So when I run now, you notice that I don't have to save it because this is already the directory we are using, so it's already saved. I just had to edit it. So once I run it, okay, source must be saved, it will save it in that file directory. You can see it's the same file directory as the same, right? So once I write my name, I'll write my name is Enoch, and then let's see, your name is Enoch. With honor in our hearts we salute you, Mr. Enoch. So basically this is what Python is. Very easy. It's high level, is interpreted, it's high level, it's interpreted, it has dynamic typing, some of the few things I mentioned in the slide in the video I created earlier. So you see this is basically what it is, and getting started, this is how your Python ideally will look like. And thank you so much. Hi and welcome to Indies Tech. This is a tutorial where we're going to be talking about Python programming skills and gradually take on how to build this skill and grow it to the level where you can carry out complex tasks. My name is Enoch, and in this video we're going to be talking about data types, we're going to be talking about variables, and we're going to be playing around it just for mastery. Very basic, very basic stuff. So for what are data types? Data types are a set of quantities that belong together and share the same category in computer programming. Quantities that belong together and they share the same category, you can place them under the same stratas or categories, are data types. What about variables? Variables are names given to computer storage location to store data. That's basically what they are. When we want to store a particular data somewhere and we give a name to that particular location, that name is a variable. So this going on to data types, this gives us like a general idea of how data types are in Python. So we are basically four: numbers or numeric, as the case may be, boolean, string, and collections. We're going to talk about them briefly and we're going to understand them and how they work basically. Under the number or numeric, we have integers, floats, and complex, and under the collections, we have list, tuple, set, and dictionary. But to give a more narrowed, and a more graphic illustration of this data type and how they are represented in Python, let's take a look at this. So this is a more narrowed way, and here in integers they are represented in Python. When writing the code is int, float, str as for strings, and bool for boolean. So the idea is that so for these categories it collects integers, numbers, both negative, so you see -1 here, 3, 100, floating you have 3.14, -0.001, 2.7818. This gives us a graphic idea for decimal points. For strings, these are for characters, alphabets, letters, words. You put them under the string data type. And boolean has basically um, you know, two operational values: true and false. For dictionary, this comes in pairs, so you could see age paired to 25, name paired to Alice. They are paired data types. They come out in a list, but they are usually paired. While a list has a list is like a collection of different data types, and it could be of different data types. Like literally you could see a string, you could see a float, you could see a string here, you could see a float, you could see an integer. So it collects different data types. So this is basically like the idea and the point about data types. However, for academic purposes, we're going to just define them literally, just so that you can have maybe a more established understanding. So next we have the numeric. This is just the definitions. So for numeric data types, you have integers. They hold and store both signs of literal numbers, so either negative or positive of literal numbers. Float stores decimal numbers. Complex number strings, we've talked about them. Sequence of characters or a single character. And yes, if you want to represent or write a string data type, you write it in a double quotation or a single quotation. For booleans, it holds and stores true or false, either of the two data. That's basically what it is. So for the collections, you have the list tuple dictionary. This is an ordered sequence of some data, and usually when writing a list, you use a square bracket and you delineate it with commas. And for tuples, the same, right? It goes the same. The only difference is that you can tweak the items in the list, but not so much for the tuple. They are immutable, and in representing or writing a tuple, instead of using a square bracket, use a normal bracket. However, every other thing remains the same. And for dictionary, the same. They are all in collections. However, in writing a dictionary, use a curly bracket, of course, with a comma, and they come in pairs. But we're going to describe these things literally by just writing very simple codes that helps you get the idea. So let's cancel this. All right, let's bring this, and then let's open a new file, and let's do something. So yes, so for instance, we want to ask Python, how do we find out the data type of a particular value? So we can use the type function, and once I type, and let's say I use true, it shows me the class. It belongs to the boolean class, right? It belongs to the boolean class. Also, if I have like maybe a number 12, it tells me it belongs to the integers. It belongs to the integer data type. How about a string? Say for instance, I write age, and of course, like I said, anytime you want to describe a string, you put it in quotation. It tells you it belongs to the class of the string. It belongs to the class of the string. Same goes for numbers with decimal points. 12.58 shows you that it belongs to the floating data type. This is generally the idea of how to use a type functions in order to determine and to know what particular data type you are dealing with, right? So in order to just play around, especially with string, let's just do something that works it all. Let's just create an addition calculator. Let's just create an addition calculator, and basically say the analogy is that we went to a storekeeper, and the storekeeper has been having hard times trying to compile or add the list of all the stocks he had or he ordered for, and we just want to create a simple calculator that just helps him to just keep putting in the value of each particular stock, and it will just tell him the total of it. And for just to make the analogy small, let's see, let's ask the all right, sorry, so it's print. Let's ask the storekeeper to enter the first stock value. All right, so first stock value, and let's store this response that he will give us in a variable called a using the input function. And again, let's ask him to enter perhaps the second stock value. Alright, let's store that also in another variable called b, and let's call another variable, let's add it to, let's just say a plus b, right? And let's print the total is, of course, C, which is the addition of the two inputs. Now there are quite a number of things that are wrong with this, but just so that you can understand, let's try to run it. But before that, we have to save it. So in order to save any of our, let's just write this as stock calc.py. okay, stock calc.py. .py is the file extension name for Python programs. And once we do that, let's see how it runs. So it asks us to enter the first stock value. Let's say the first stock value is 12 and the next one is 3. 12 plus 3 is not 1, 2, 3. So what happened? Now, of course, you have the idea that the basics ideally, you can even use it as a calculator to say 45 plus 62 plus 65. Once you press the enter button, it will give you the total value. So, but what's going on here? This is to show us that we did not tell the program that this particular value that will be entered by the storekeeper is an integer data type. We're expecting a number, a numeric data type. So because of that, what basically this program did was that it puts together 12 and 3. 1, 2, 3. It puts 12 and put 3 together. It just joined them together because that's what C is, joining them together, but it doesn't know what it is. It just retained it. So in order to do this, because you see, of course, you could use let's try to run it again. If we ask it, we could just press size, okay, save me, right, save me, right, but it's not what we asked it to do. So in order to make some specificity to it, we can add that this whatever value that the storekeeper enters should be stored as an integer data type. You see where the idea of the data type comes in. Integer data type. And once that is done, let's try to run it again and let's see what happens. So it asks me, I write 12 and the next one was 3 again. It runs it to 15. Now it adds it because it understands what exactly the storekeeper is writing, because you told it that it belongs to the integer data type. What happens if this program, for instance, is 12, and then let's say the second stock is like the weight of the stock? The value is like the weight of the stocks, and perhaps it's in decimal. So if I write 16.5, it will run an error because this is not what was described to it. So in this case, having known that the second value could be a float, I could just define it as a float, seeing that the values could take decimals, right? So when I just do that, if I can just do any of that, and I try to run it, I say 12. All right, let's make this afresh. Yes, I want to kill it. All right. Okay. So 12. Let's just try it again. So I say 12 and then 52.5. 64.5. It makes a lot of sense. So even if I run it again, say I run it again and I write 12, and it's still not a problem. 57, even if they were all integers, at least it helps me to um circumvent the error issues that I have. So this is like the idea of working with this. So you want to ask, how about the boolean, how about the bool, and how do we work with the boolean data types? Usually I think it's high time we know that there are certain operators in Python, and it's good to familiarize ourselves with that. So I'm going to define it, and I think that will help us to understand. um okay, and then we have less than or equals, then we have the not equal. Is presented as this. So these are the six basic operators we have basically. So remember, this A, of course, mathematically you want to say A equals to whatever the integer the stock keeper or the stock keeper here puts. At this point, this is an assignment variable. This is an assignment operator. It assigns the value or the data the user puts into A. it doesn't say that A is equal it. So if you want to talk about equals, this is the sign, is the double assignment variable, assignment from assignment operator that shows what it is. Equals, this is greater than, less than, is greater than or equal to, is less than or equal to, and this is not equal to. So for Boolean operations, of course we said it has basically either true or false. And like we see, let's do something. 12 is, just understand it, 12 is less than 13. 12 is less than 12, to say false. But if I do 12 is less than or equal to, all right, okay, let's just 12 is less than or equal to 12, it will show a true, right? So this is basically how the Boolean operators, and usually they work when we are dealing with functions or we are dealing with flow control statements for loops and all of that. But would see that in some other video. So in this case, this is basically what it is. So let's also talk about the list operators and dictionary before we wrap up this video. So let's open a new one and call it list operations. So again, the same analogy, let's go to the storekeeper and see, for instance, for a particular stock, the storekeeper wants to take the details of that individual stock. So for instance, let's say my name Enoch is a stock, and then of course using a square bracket we want to list out the items in this particular variable, as it were. So let's say I'm 24 years old of age. Let's say for instance I love orange color, right? Of course orange is a string, so I represent it with a quote, double a quote. I weigh 52.6 kilogram. And is it true that I'm positive minded? Yeah, it's true. Alright, so I deliberately use this to represent the different data types. So we have an integer data type, we have a string, we have a bool, a floating data type, and then we also have a boolean data type. Now basically I use this to call this, so I can just ask the program to print Enoch, right? Since that's what it is. So if I ask it to print Enoch, yes, of course I'd have to save it. So let's say operation list.py. Alright, so once it runs, I asked it to print Enoch. So you see here it showed all the items that Enoch is, and of course it has a wide range of applications when writing Python. So like mathematically we want to say this is the first item, second, third, and fourth. No, in Python how we rate it, it starts from 0. So this is the 0th item, this is the first, second, and the third, right? So in case I want to call any of the items in this list, say I want to call the weight, so I would just call the third item and then close it and then run it. You could see it calls true. The third item is true because it's 0, 1, 2, 3 is I'm positive minded. So if I want to call the second item or the first item, which is my favorite color, all right, so I will just run this. I'll just press F5 and it brings orange. This is like the idea for a list operation. However, the same goes for a dictionary. Let's just double this as dictionary. All right, so in a dictionary the difference is that it uses curly brackets and then it comes in pairs. So yes, now I can categorically define what these individual variables are. So for this first one, or individual items are, for this first one is my age, second is my color, and then third is my weight, my weight, and this is, but all right, so let's code it as being positive minded, positive mind, positive mindedness, right? Let's just put it as that. Right, so this is what it is. In this case also I could just call Enoch. All right, let's just run this again. Yeah, okay, let's just run this again, and I call Enoch. It brings out all the items within the dictionary. But now um if I'm gonna call any individual item, of course, now using a square bracket, I could just say, all right, can you fetch me the age? Can you fetch me the age of that item in Enoch? And then we run it. It will fetch me my age, but it will fetch me what my age is defined as 24. My age is defined as 24. And the same way I could ask it, could you fetch me the weight um in Enoch? And once I do that, it will fetch me the weight, which is 52.6. So, and it has a wide range of applications. This is just to give you like a general idea of how data types and how it works literally. And so thank you so much for staying true. Thank you so much. In this video, we're going to be talking about Python programming skills, and we're going to be discussing some of the components build ups in getting our hands um, very strong so that we can become skilled programmers and knowing how to use these foundational things in order to get jobs done. So, once again, I welcome you to Indis Tech, and my name is Enoch. So we are going to be talking about flow control statements, the if, the while, and the for statements. Generally, they are called loops, right? So we're going to talk about that in a bit. So we're going to be talking about comparison operators. We're going to be talking about Boolean operators, break and continue statements. And of course, as the saying goes, you don't know it except you do it. So we're going to write some codes for mastery, because if you don't do it, I can assure you, you would never know it. You would assume that you do know it, and there are many things there's something called muscle memory. Except you practice it, your muscles will start getting acquainted with it. So without wasting so much time, let's see. So this is a typical diagram that tries to explain what flow control statement is. So this is a chart that shows if you should go out when it's raining or not, right? So the statements, the program starts from here. So there's a condition here. Is it raining? Is raining? And then if yes, then the next condition comes. Do you have an umbrella? No, it says you should wait for a while. But if you have yes, it now says go outside. But if it's raining and it's no, is it raining? No, then you can go outside. But if it's raining, if it's yes, you don't have an umbrella, wait a while. While you are waiting, the question comes again. Is it still raining? Is it raining? Once it's a yes, it goes back, it directs you back to still wait a while. But if you can confirm if it's no longer raining and it's no longer raining, then you can go outside and the program comes. So there are many programs that you would want to write that would follow, that will have these many branches, where in order to be a lot more productive, you'd have to branch in different other places, and in order to get these questions, these conditions in a program, there's a way to depict or give the instructions to a computer in order to get it done, especially in Python programming, and that's exactly what we're going to be doing today. And in order to do that, there are certain operators that we ought to have ourselves well acquainted with. They are called comparison operators. They would help us put our conditions very well. So in order to give these conditions properly to Python in Python programming, then you would need to learn them. And of course, as you can see on your screen, equals, not equal to, less than, greater than, less than or equal to, greater than or equal to. These are the 6 comparison operators that we have in Python, and look at how they are represented when you're writing a Python code. All right, next we'll talk about Boolean operators. Of course, there are three Boolean operators: or, and not. And I don't know. Some of us that had acquainted with mathematics, logic, I think we should be able to be acquainted with this. But I think we'll try something here. So in the AND operator, it evaluates to false anytime the combination has a false, but except when it's the two conditions are true. So when it's true, you get a true. When it's true false, anytime it's with a false, it evaluates to false. So for instance, I could say 2 is greater than, okay, so 2 is greater than 2. If I should do that, and using the operator, you see, and it changes to an orange color because it's a function, is an inbuilt function in Python. 2 is greater than 2, and 2 is less than 2. Now these conditions are both false, right? If I should hit the enter button, it will evaluate to false. You can try any of these conditions. So let's try it for you. True. So true. In order to do this, I can just hit here. So true is equal to true. Remember, this is how you represent equal to, and 2 is equal to 2. Once it's true, it evaluates to true. So in your convenience, you can try this other on your IDLE. You can just pause the video and try it out and see what it will give you. So you have the or. So this is the next, the or truth table. The or evaluates to true every time the combinations is true, or every time in the combination there is a true, except when the both conditions are false. So except this time they are false, whatever way it is, it will evaluate to true. And again, we'll try this for just two of them. You can try the rest in practice. So for instance, we want to do that 4 is greater than 2. Of course, that's true. And then we want to use the or operator. And then we also want to say that 12 is less than 32. They are both true, so it evaluates to true. And if they are both false, that's when it evaluates to false. So 4 is less than 2, and 12 is greater than 32. So when they are both false, otherwise it's true. So you would want to confirm this by trying it out. And of course, you can even type this directly on your IDLE, and you will see true and false will give you a false, right? You could do this with the or operator, and then it evaluates to true. So you could try this anyways and get it done on your PC. So yeah, the not operator evaluates, just what it does basically, it just evaluates to the very opposite of it. So when you have the not operator, not true. So when I say maybe not true, of course, all right, the not is supposed to be, I had an indentation, so it's not supposed to be. So once I do this, it falls. So it just evaluates to the very opposite. So you could try the rest too again. So next, what are we going to be talking about? Let's continue fully, and break and continue statements. Now these two statements are usually used when you're having a loop, when you're having um a loop, like in order to keep, when you're doing something within, especially when you're talking about conditional statements like if, for, and while. This is usually the context to which we use break statements and continue statements. Now this statement is used to break, for a break, and this, the bracket is how you write it on in Python, break, with a small letter, or in small letters. This statement is used to break a program out of a loop without checking the condition again, so that anytime in a loop it gets to the break statement, it doesn't even check the condition anymore. It leaves the loop. It's like an automatic, it's like an emergency exit. Once you hit this exit, it just leaves the loop completely. For a continuous statement, what it does is that once we, when the progression of um program, when the execution, of course, in Python, codes are executed line after line. So when the execution goes down and hits a continuous statement, when it hits a continuous statement within a loop, It doesn't continue the, because every time that you are writing a loop, it finishes the instructions within that loop, then goes to the conditions to check again. But when you have a continuous statement, as soon as it hits the continuous statement, it returns, it reverts back to the condition, regarding less every other lines of code that are below it, that are beneath it. So once the continuous statement, this statement is used to loop, to make a loop jump back to the condition without completing the loop. It's like a recycle. As soon as it gets to the continue, it hits it back and it goes back to the conditions. And of course, practically, we are going to see it in a while. This is just basically to give us an idea of how it works. So quickly, we are going to start with the if statement, and we have a syntax here, and of course, we are going to practice. Even we have a project to do here. So the project is that we are going to validate a staff user in this step. We're going to validate a staff user. Of course, we'll just ask him a few questions, and if he's correct, we'll validate that. That's the project. All right. So okay. So all right. This is the syntax of the code. So let's open a new file. In the file, let's open a new file, and we'll try to see how the syntax goes. But in order to do that, let's write a code. Let's write a quick code that will just, just show us how the syntax work. So for instance, let's print welcome to Index Tech. Oh, okay. Let me just do welcome to Index Tech. And then let's ask the user to print their name. So please, all right. But of course, I could just, need to write the print function. Print. Please enter your name. So once I do that, let's use the name variable to collect whatever the user is going to enter from the keyboard, and then let's use this. So this is the condition. So if they now ask us the condition, so if the name is Alice, of course this is equal, and since Alice is a string, we have to put it in with a quotation, and of course the input statement returns a string. So if the name up, then we'll now put a semicolon. Are you seeing the condition? So if, then the condition, then a semicolon. So if name is a condition, semicolon, then an indent is created. But let's just finish. So print hi Alice, hi Alice, else print hello stranger. It's supposed to be a stranger. Now we'll run this code. So but what does this code say? So the output will show a print to welcome to Indice, to ask the user to please enter his or her name, and then this code would receive whatever it is the user inputs from the keyboard or from the keyboard of his PC. Then here the if statement comes. You see the syntax here. So if the name, these are conditions that we have here, then we have a semicolon, then an indentation. Did you notice some sort of a line between the if and the line? So, and that happens here. Once you use the semicolon, an indentation is created. So a block of code is written within the indentation. So anytime you're having an indentation, this shows us that we are having a block of code. from this if and else, this is a block of code. This is a block of code, and we have a block of code anytime we have an indentation. So it says if name is Alice. Now what happens is this: once the condition is met, then the execution breaks into the block of code and executes whatever is in the code. If the condition is not true, it never breaks into the condition of the block of code. It jumps this block of code and continues the next line. It comes to the else, and this after this else, there's an indentation again to say that if this is not met, that means this should be met. Basically, that's what it means. Then this block of code is printed. This block of code is executed. So that's basically like the idea. So if we are to run this, of course we'd have to save it. So let's save it on our desktop as if statement. So right, let's just say on our desktop as if example. Okay, example.py. Of course we know that py is the file extension name for Python code. So let the output come out and let's see what works. So it comes here, said okay, enter your name, and I print Enoch. Once I typed Enoch, this was not the condition, so the condition was not met. The condition was this: that if his name, print hi Alice. If it's not met, print hello stranger. You see that's what's being printed out, hello stranger. Let's rerun this. Let's just press F5 and rerun this code. So what if I use Alice? Said hi Alice, right? So in order to understand this fully, let's consider a flowchart. Now consider this flowchart and see what's going on here. So the program starts. This is the condition: name is it Alice? If it's true, print hi Alice, just like we tried to explain the other time from this, right? So if it's true, print hi Alice. Otherwise, if it's false, print hello stranger. So that's exactly what you see here. Then the program ends. So this is like the syntax of the if statement. And of course you can have multiple conditions. That's where we're going to talk about the if and the elif statement. So this is a condition for the if and elif statement. So let's imagine. So this is exactly the same thing you see here. So the condition, the once the column and indentation, then the line of code if this condition is met. But you could have different other conditions. So else if this condition, right? So this is the elif, is like else if, right? So else if that condition is not met, how about try this condition, try this other condition. If this is not also met, try this other condition. And if all of them is not met, just print, just continue on this line, right? That's basically like the idea. And is also to note that in case these conditions happens to be true, it never continues, the program never continues to say okay, how about let's try this. Once any condition is true, it breaks into the code, and that's it leaves the whole loop, it leaves the whole conditional statement and prints out. So let's try something. So let's assume also from this code that we are having multiple users in this tech, right? So let's say this was like a staff website, and for the staffs you have to put, you just enter your name. Once your name is open, it just say welcome, right? So let's just use the word welcome Alice, right? So let's assume that Alice is one of the staffs, and we have like maybe just 3 staffs, right? So and I want to write another, so I write elif name is, say Enoch is another staff, so Enoch, if that is true, then print welcome Enoch. And again I have another condition, say elif name is equal to, let's use the founder of in this tech, Ahmed, that's his name. So if name is equal, if that, then print, if that condition is met, print welcome boss. So in this I've given multiple conditions to it. Let's say sorry you are not a staff. So yeah, if we run this code, let's just press F5 and then run this code and see what happens once this code is run. And so notice exactly what welcome to Indies Tech, please enter your name, and in case my name is Enoch, I put Enoch. I have a condition for Enoch. It welcomes Enoch, right? It welcomes Enoch. Let's run it again and see. Let's run it again. So let's say for instance I use the CEO enters his name as Ahmad. How did we? All right, yeah. For this, let's say Ahmad. Say welcome boss. How about if any other person tries to log in, try to log in into into the system and say his name is maybe Frank. Sorry, you are not a staff. That's basically what it checks the condition. And once it was Enoch, it didn't have to come back to check if or say any other thing. Every other conditions is neglected once any condition is true, and it continues in the line of the code. So that's basically how if statement is. And I think this helped us to write our project. Let's check our project again. Evaluate stuff in this. I think we've run the project already by trying to explain it. So these are the stuffs, and we validated the stuff. This is basically our project work, and I think we can go ahead from here. So what about the next statement, the while statement? Now the while statement basically it takes the same idea for the condition for the way loops occur. However, in this what happens is that the line of code is checked. It continues when the condition is met. This basically the syntax, right? When the condition is met, this loop will not stop except this condition is false. So you see, for the if statement that we have here, once it's true, it breaks in and does this. But for the while statement, it will keep repeating the loop until the condition is false. And of course, if the condition was false in the very first place, it never breaks into the indentation to do this. So in order to do this, let's just let's just create a new file. Let's create a new file. Let's delete this. Let's create a new file, and let's run a code that prints hello world 5 times. Let's just use, because of the flowchart we have here, let's write that same code. And we'll have a project here to do, so we'll try to solve the project as we go ahead. So let's say print, of course you can name your distance for clarity using the hashtag, which is basically a sign for comments, and every comment is a non-executable line of code. So anytime I use a hashtag, it will make sure, it just helps me to understand what I'm saying. I can use that to comment, that's the word, but it doesn't execute that line of code. So let's just write while statement practice. Let's just leave it there. So let's just print again. Let's say we're just doing it. We'll always welcome it, our culture to always welcome people to our classes. So welcome to Indies Tech. Right, welcome to Indies Tech. And then next we see, all right, so we want to print a code that writes hello world. So let's initialize a variable, because we want to use it in the condition. So let's say that let's use a variable spam, just because of the flowchart we have next, just to understand it. This is an assignment variable. Now you see the difference between equals to and literally in the usage. This is an assignment operator. This one equal is assigning one to spam. So spam is the variable. It's assigning one into the spam. So it's an assignment variable. But if I use double equals in this manner, it will mean that spam is equal to one. This is no longer a variable. This become a condition. So this is an comparison operator, while this is an assignment operator. So yeah, so let's say that while spam is less than 5, of course, print hello world. Once I do that, then let's increase spam plus 1. All right, so what will happen when we run this code? What will happen is this. So it initializes spam as 1. So you have a spam, because of course if you're bringing a condition in, the program should have understood what exactly is going on. Is this, what is this? So you have told him that this is a variable and it carries 1. So he checks the condition. What is spam here? Spam is 1, and is 1 less than 5 is true. Once this is true, it breaks into this code, this indentation. It breaks into the block and runs this. So it will print hello world. But before it goes back to the condition, there's another line to say that spam. What was spam? Spam was 1. So 1, okay, yeah, spam was 1. 1 plus 1 becomes 2. You have assigned spam a new variable to be 2. So it has increased. So we call this incrementation. We've increased the spam value. So once this is now 2, it goes back to the condition again, because while we will keep going back, it will keep running this except this condition is false. Once it's 2, you say 2 is less than 5, that's correct, it will continue again. By the time it gets here, it has, because it was 2, it will now be 2 plus 1, it becomes 3. And again, it checks again. Is it less than 5? Yeah. It will keep checking this thing. But it now gets to 5. Is 5 less than 5? It's saying no, 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 no. Because it's no longer there, it stops. So maybe when it stops, say let's get an output that says print we have to stop here. Alright, we have to stop here. So let's run this code. Oh boy, what did I do? Alright, so let's run this code. I just did F5. So of course we have to save it. Let's save it in our desktop as let's just say spam.py. Just spam, just to help us run the code. So when this code runs, what goes on? Let's see. So you see what happens here. Hello world, hello world, hello world, hello world, 4 times, right? It says we have to stop here. Once it got to the end of this, you have to leave the loop. At this point, this condition is not true. It will go back to the next line, and of course it will go back to the original indentation. Is there anything here? We'll get it done. So that's basically like the idea. And someone will ask, but this thing is 5. We said it was less than 5. 1, 2, 3, 4. We didn't say it should stop at less or equal to 5. So if we want it to 5, we say less than or equal to 5. And once we run this again, I think it should come out with 5 outputs now. So you see 1, 2, 3, 4, 5. You see, that's basically what it is. So but in order to also have a graphic understanding of what this is, let's check the flowchart that describes it. So this is it. So it starts here. Is spam less than 5? If it's false, of course this flowchart doesn't have this, right? So if I delete it, it will end, right? Because it doesn't have it. But if it's true, it will break into the code. And what is in the code? Print hello world. Say okay, I will print it. Next is it increase spam by 1. Say okay, I've done it. But once it does that, it would not continue to the next line. It will go back to the code and say, is it true? It's almost to say as if you send it on an errand to confirm. Is this errand correct? Done properly? If it says not done properly, do it again, it runs again. If you say it's okay, then it breaks out. So that's basically like the idea of the spam, of the while statement. Okay, and we have a project here, and the project is that we write a program that solves the factorial of a number. But in order to do this, I think we'd still have to use this code. All right, let's just create a new code. Let's just say um let's type let's comment as factorial, say object 2.0 factorial. Alright, so let's just call it like that. So we have to understand how does factorial work. So the formula for factorial is largely this. So we have factorial n, let's say n, any number will now be n into n minus 1 into n minus 2, and it continues like that, of course with a multiplication. So this is n multiplied by, all right, n multiplied by n minus 1 multiplied by n minus 2 multiplied by, it goes on like that till it gets to 1. This is a basic formula for factorial. So we want to code this, we want to automate, we want to create a calculator that solves factorials of numbers. Having this known, then I think we can try, right? So if we have int enter any number, because the project says any number, enter any number. All right, enter any number. All right, so let's stop here, and then again, of course, we would ask it to, once it enters this, we want to call this val, right? That's a value. Want to assign that whatever input the user puts in, let him store it for us as val. And once we have that, then let's say we have another one, this thing that says factor. Let's just code factorial to be factor, and then of course let's initialize it to be 1, since 1 is like the base. And of course there is something that is called identity in mathematics, such that any number multiplied by 1 is the same number, right? That's like an properties of some of that. So 1 is an identity value. If you multiply it by whatever identity, that retains its identity. So having known that, let's just have this. So let's use the syntax here. So we have the while, then we have the condition, semicolon, then we have our so let's use the function while what's the condition? Factor. Now while factor is less than 1, let's just say while factor is, okay, while the number that the person puts, let's just use val. So while val is not equal to 1, let's use this, right? This is a condition. So we have while, then the condition, then the semicolon. So this is while. We have val here. We had assigned that whatever number the person puts, let him save it to us as val. So we have while val is not equal to 1, because the factorial of 1 is basically 1, right? So we will write a code for it, but while factorial, while the value is not equal to 1, okay, let's just make it write any number not equal to 1, because let's limit our calculator to that knowledge. So while factorize it, so what does he do? He should just do that factor. We'll try to implement the formula. That factor should be factor multiplied by val. So basically what we have here is like 1. We had initialized factor to be 1, and once factor is 1, okay, let's just finish the code, and of course let it be reducing val by 1. So we have a decrementation. In our example we had incrementation. Once this, I think this should capture print factor. Now this should solve our problem, because you see, once the user puts any number and we have initialized factor to be 1, once that number is not equal to 1, it will break into this code and it will do factor. Here factor is already 1 times is that number the person puts, and of course that will give us n. Then we now reduced it to be n, reduce the n as it were, the value, reduce the value by 1. So we reduce the value and checked again. Is the value still 1? The value is no 1. It now be like, okay, so n, that factor, which is, what's the factor now? The factor is, will now take on the new value times that. So that, for instance, in order to understand this, let's make a graphic. So let's say 5 factorial. So if our 5 factorial should be equal to 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. So the thing is getting multiplied, but by the reduced number. So, and that's exactly what is going on here. That's what is going on. It's just reducing this value, is just reducing the value, and we go on. So if we do 5 factorial, this should be 5 times 4, 20, 20 times 3, 60, 60 times 2. So this should be 120. So, but let's run this. Let's run our calculator. Of course, okay. Let's comment on this. Otherwise, it would want to run this. So let's comment on this, and yeah, we can run this. Of course, would have to save it as let's just save it as factorial. That's py. All right. Once this code runs, let's see how it looks like when it does. Oh, it's not getting full. So let me just, yes, please. F5, and let's see. So the program has asked us, okay, we should enter a number not equal to 1. Okay, let's do 5, right? All right. There's an error here, and what's the error is that we remember the input function returns a string value. So I didn't tell him that, I didn't tell the computer or the program that the function I want should be an integer value. Once I get that corrected, and I think it should now run. So let's try. So here it asks me to enter any number. So let's put 5. You see 120. Now in this case we had run this open. So if I should run this, let's say F5 again. I just hit my F5 button, and let's choose any number. 6. The factorial of 6 is 720. So this calculator just keeps doing this. Any factorial you want, any number you want, it will run the factorial of it. Let's say 54 factorial. This is it. This is exactly what it is. So I think we've done our project, and we can continue with our video. So yeah, so now this is the loop statement. In the loop statement, all right, so in the loop statement, this is exactly what it is too. It's also, the syntax is, we'll have 4, then we'll have a variable in range. Of course, please, let's pay attention to this. Variable in range. Okay, so variable in range of, then another, then the condition, then you have the semicolon, you have an indentation, then you have the line of code. So this is basically, okay, we have a project here too. So this carries the same idea. We've been talking about these loops for quite a while now, so it carries the same notion. And in order to get that done, let's open a new file editor. We can delete this, and we'll have this here. So let's just run our code, our project with this, and see how it goes. So the project is that we should write a code that sums even numbers from within any given range. So all right, so let's ask the user. Of course is a custom. We welcome the user. So in this text, and then again we have print. So let's say that all right, sorry. All right, let's say that we are going to be having, all right, I think we opened another one. Yeah, so let's say please enter, since we said any given range, we need to get the upper limit of the range and the lower limit of the range. So let's just use enter the lower limit of the range. Enter the lower limit of the range. Okay, and whatever the user should enter, let's write it as lower LW. Let's save it as the input. Of course, is an integer, since you're talking about um the range. It should give us within an integer. Then we ask the user again to please enter the upper limit of the range, and let's say up as upper. Of course, is an integer. So since this was gonna normally return a string value. So once we've been able to establish what's the upper limit and the lower limit of the range, then I think that we should also have a variable. Let's use the variable sum, and let's say sum should be, let's initialize sum as 0. Sum as 0. Well, sum is a function, so let's just use word cal, right? So cal equals 0. So we're going to use the for loop now. What is for loop? For loop continues to, like we also said, it enters if the condition is true. So if this condition is true, it will break into this line, this block of code, or these lines of code. And once that is done, what happens is that it begins to it's used for making a program to repeat itself for a given number of time. So on while statements, what it does is that it does a code repeatedly until the condition is false, right? Until the condition is no longer met, it will keep repeating the program. It's basically called iteration, to keep doing it over and over again. If basically what if does basically is that if checks this conditions, once is correct, it breaks in and carries it out. But for it will do it within a specific range, within a specific time or limit or boundary, right? That you would put for it. So in order to call the function, so we have for let's say variable I, for I in range. See the syntax, I'm still using it for variable in range. Then you have the condition. So again, you see we said that the condition, the limit should be is determined by the user. So of course the lower limits, so we saved it as LW, and of course in range we separate it by a comma, and just the way we are writing it out now, range then upper limit. Okay, they said even numbers. All right, so in order to understand even numbers, again we need to understand how is even numbers, how do we get even numbers. Logically, even numbers are numbers that can be divided by itself by its 2 without having a remainder. So take for instance, you have any number you can divide by 2 without having a remainder is an even number. That's the general definition of even numbers that we have. And one easy way to get is that is in the multiples of 2. That means after every 2 steps you get an even number in the order of numbers. So for instance, let me comment on this and have 1. All right, so let's say we have 1 comma 2. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. How do we get even numbers? After every second step. So after from 2, counting after 2, 1, 2, the second will be an even number, 1, 2, the second will be an even number, 1, 2. So that's basically the idea, the trick we're going to use for solving this. So in order to do this, we know that we can add another step. All right, so somebody may be asking, what is this step that you are adding? When you want to run a code, when you're defining a range function, you have the lower limit and the upper limit. If you have another third variable, if you have another third what will I call it now? If you have another third item within the range, is basically the steps. It means the number of steps it will take between these two range. Between these two, yes, range or sets of values, the number of times you should take. So after two steps is called step value. It's usually the step value. So of course we put the semicolon just like we saw here. Let me make it a lot more elaborate. So we have this, yeah. So once this is done, then we ask it to, if this condition is true, what does it do? We should sum it. So we have sum, we are okay, cal, we use it as cal should be equal to cal. Of course we had initialized cal to be 0, so cal should be cal plus this I. This is a variable now, right? This variable. And once this code is done, once it's done doing this within this specific range, let's ask it to print cal for us, which happens to be the sum of this. So of course, if we are going to sum, let's say, let's still check if the even numbers here should be 2, 4. All right, okay, let's do it plus 2 plus 4 plus 6 plus 6 plus 8 plus. All right, we're going to see something here. So this is the range, say between 2 and 10. Okay, so just to save time, here you see that it didn't get to 10 because this upper limit is usually not counted. It's usually not counted. It just defines the range, but it's usually not included in Python. That's how Python works. So if we want to include it so that our calculator will be a lot more accurate, then would have to add 1 to just increment it by 1, having known that it will not count it will not count particularly with the limit of the boundary. It doesn't calculate with the limit in view. So in order to do that, then I think I should get maybe another variable. Let's call j, or yeah, let me just call it j. Let me ask it to be up plus 1, so that this would help me make it more robust. And instead of having the upper limit here, I want to have it as j, so that I can include the very limit in the calculation. I can include the very limit in the calculations. We're going to do something just to check it. Let's save this as, let's say, what's this? Okay, even numbers, even sum. Let's just do even sum.py. Right, so once we save this, let the code run. Once it's running, let's see how it's gonna. So let's say it said we should enter the lower limit of the range. So let's say the lower limit is 1. Okay, let's say 1, and the upper limit is 10. You see it's having 25 here because it's having 25 here. Why? Because we said it should start from 1 to 10. The number should be 1, should be, what's it called, it should be within 2 plus 4 plus 6 plus 8. Okay, we added 10, right? It should be plus 10. Why is it giving us 25? Because if we add this is 2 plus 4 is 6 plus 6, 12, 12 plus 8 is 20, 20, it should give us 30. I think it's because we said that the lower limit should start from 1, and once it's starting from 1, it will start its movement from here. So if it starts its movement from here, it's going to be 3. So let's see again. Let's run the calculation together in the way we wrote the program. This is also to show that the computer will just keep doing what you ask it to do. So if we have 3, because it wouldn't count, okay, it wouldn't count from that limit, so it will start from 2. So we have 2 plus, it will now move 2 steps from 2, 1, 2 plus 4. All right, okay, 1, it will move 2 steps, so we have 3 plus 5 plus 7 plus 7 plus 9. So if we were to do this, this is 8, right? If this is 8, 8 plus 7 is 15, 15 plus 4, 15 plus 9 is 25, 15 plus 9 is 24. 24. So what happened here? All right, why don't we reduce, since we know that the lower limit is usually is starting from, it's not including that limit. So why don't we just have a limit within. All right, let's try something. All right. Okay. Yeah. So we are trying to evaluate what's going on here. So we said that this. So the program is going to start from 1. So what it will do is that it will do 1 plus. It will now move from here to the second one. From here, it will start from here, having 1 at its first, 1, 2. It will start from 3, which will violate the conditions that we have for it. So in order to get even numbers, we would either tell the lower limit to always be 0, but our project says that it should be any given range. So let the user be the one that determines the range of of the value, right? So in order to do that, knowing the way Python works, we had to add 1 to it so that it will include the range from here, and then we also need to allow it to start counting from 0. We need to allow it to start counting from the number before the lower limit. So just like we incremented 1, I think we should also let's say k j, let's can we use another value, say m lm, right? Lower limit. Let's just use lm as the lower limit, and the lower limit should be the lower limit, that the lower width, let's just use lower of the user minus 1, and then this, let's just call this ul, upper limit, right? So we'll now be having lower limit and then upper limit in increments of 2. The idea we are trying to run here is so that we don't have these kinds of errors, because like we saw in this program, what happened was this is when we have 1 here, it becomes 25, right? The answer becomes 25. But this violates exactly what we are trying to do. We need it to ensure that the lower limit starts counting from exactly that lower limit, knowing the way range. Okay, let's see something. Let's ask let's use the length function of 1 comma 10. Will this run? This is not supposed to. I'm supposed to give it like all right. Let's say, let me do this. So let's define Enoch. All right, let's just say um class class this class is having this range between 1 comma 10, right? Okay, class is a function. I need to use another value, another variable. I say clan. All right, so clan should not be a function. And if I were to do that, I would have what if I want to access the length of clan? I don't know if I can do that. We're all learning, so let's see. It shows me that the length, it doesn't give me the range. Doesn't bring the idea I wanted to pass. But the idea I wanted to pass was this, that you see the range of a function brings out the values. I would have used the dictionary, but it would take me a lot of time, and we don't have that now. So it brings out the value. We want it to start counting exactly from the lower limit and the upper limit. And in order to do that, we need to go one step backward so that it will start counting from exactly the value, and one step forward so that it will end exactly at this. That's the reason for all of this. So if we run this code ideally now, let's see what comes up. If we run this code ideally, let's enter the first range, the upper limit as 1, and it brings 30, which was the original. Of course, if we do this, it will give us 32 plus 4 like we did earlier. It gives us, and it brings a lot more robust or accurate perspective. So if I should run this lower limit and of the range, so let's use another lower limit, 25 and 50. This is an accurate number of of a calculator that sums even number using a for loop. So that's like the idea for a for loop. I think we are done with this project and we have an overall project to carry out, and this would help us incorporate these statements called the break and the continue statements. We had not used it. So in this project, it asks us to write a more robust validation code with break and continue statements. Quickly, let's just run that. Okay, let's open a new file and let's run this and see how it works. All right, so quickly print all right, welcome to in this um so in this we're going to make a few assumptions, and we're going to assume that we are having all right, let's see, let's assume that we're just going to write a simple password checker, but it has break and continue statements. So in order to do that, let's say print welcome to Indis Tech, and while, let's say, of course this is a while, all right, okay, while true, okay, let's assume, since it's a more robust one, um this is for staffs only. Let's just use this is for staffs only, and while this is true, if this is true, and of course it's true, while it's true, we're using the while statement. Print um please enter your username, please enter your username, and once the username is being entered, let's save the username as name. Okay, let's use user, and let's assume the user to be an input, and of course the username is a string variable. So when I want to write another condition, if user, using the syntax we had, if user is equal to Enoch, if user is equal to Enoch, if user is equal to Enoch, or let's say if user is not equal to Enoch, just a password checker for time's sake, just a password checker that's just permits Enoch, right? So if user is not equal to Enoch, let's say continue. Now we'll get to see what this is, but if user is equal to Enoch, then print welcome Enoch, um please provide your password. Okay, your password, right? Please provide your password, and whatever the password is, let's call it code. Let's just call it code as password, and of course impute. Then we have another condition. If the password, if the code, again another if statement, if the code is equal to, let's say that the password is Enoch 2024, Enoch 2024, right? If that's the password, of course with a semicolon. If the password is correct, break. This is just basically trying to use the continue and the break statement. Otherwise, if it's not the password, if it's the password, do that break. But if it's not the, and what you break out into is what you break. Okay, break. I can still use break. Let's say print access granted, right? Access granted. So, but if it's not password, it would if it's not password, it would let's can we have an else statement? um yeah, I think we can have an else statement here. Print wrong password. I think this code should run as at least it has the continue and the break statement, and I think it's a little bit more robust than the other one that we did. So what happens here is while true, once the user, of course, this is true, this is for staffs only. If you have gotten here, it means you're a staff, and that is true. And if it is true, print enter a username and it collects it as user. If the user is not Enoch, this continue statement will go back to the condition, and of course the condition is true that is for staffs only. It will still ask you to print your user. All right, let's just run this, right? And let's save it as final project before we call it a day, right? Final project .py. All right, let's save it as final project, and then let's run the code and see. Okay, yeah, this is an assignment variable, so sorry for that. I think it should work now. So welcome to IndexTech. This is for staff only. So if you have gotten it for staff, and that's true, because it's true, it ran into the code to say print your username. And say for instance, I used user. Alright, let's say the username is I use tech. It's let me print my username. Do you notice what's going on here? Because once is not Enoch, it cannot break. Once it's not Enoch, I told it if it's not Enoch, it's true. There is no it will go to continue. The continue statement goes back to the condition, and the condition is true, so it continues this code. It will keep doing this until you write the actual code. If I write user, it will still ask me to print username. So in order to do that, I know that the username is Enoch, and it goes on. Because the username is Enoch, it goes on to say that I can. Yes, so because the username is Enoch, it goes on to say that I can enter the password. So it's breaking into this code. Please enter your password. Say I wrote another password that is wrong. Okay, the password is, I told it next code is if the code, so you save it as code. If the code is Enoch 2024, it will break. So let's just, for time's sake, let's just Enoch 2024. It goes back to wrong password, so I have to go back to the username again. So let's Enoch, then I have Enoch 2024 access granted. So once it hits is true, it will break, and this break means leave this loop. It doesn't even matter what's next below. It just up is an emergency exit, like we talked about. Emergently or immediately evacuates. It leaves this entire loop and then goes back to the original indentation to print access granted. So this is more robust, and I think we can call it a day. Thank you so much, and see you next time.